We will be discussing about how to go from time domain to frequency domain. And we know it depends on signal, means what type of signal we have in time domain. Accordingly, there will be different methods, a mathematical formulation to go into frequency domain. Let us suppose our signal, let us suppose we represent it as x of t. Let us suppose this x of t is periodic. What does periodic mean? We have discussed it before also. Periodic means it is going from negative infinity to positive infinity, and it repeats its pattern after some, it repeats some pattern after some particular time interval t. We can say t naught. So we say that if there is some signal, let us suppose this is signal. If there is a signal, if it is going for the condition, it is going from negative infinity to positive infinity, means it is repeating here and here, negative infinity to positive infinity, and there is some pattern. Let us suppose this is pattern. It is repeating this pattern for some particular time t, and we say that t naught. This t naught is called the fundamental time period. Means with this time period the pattern is completed, and we say that this is the one cycle of the signal. Okay, so now this is the time domain. How to go into frequency domain? So first analysis. We have continuous signal. In time. This implies whenever there is something continuous, we know there are infinite number of samples here, so whenever there is continuity in the time domain continuous implies frequency domain will be, when time domain is continuous, frequency domain will be aperiodic. Why? Because if we are having, this is our time, and it is continuous, means there are infinite number of time intervals here. So for every t we are having some sample here, and these samples are infinite. Even if we take one period only, there are infinite number of samples. So with that we say that whenever we are having continuity in the time domain, in frequency domain we are having aperiodicity. Why we are having frequency domain aperiodicity? Because the number of samples, because the number of samples are here infinite, so we are not able to actually repeat the frequency domain. In frequency domain we can repeat only if we have completed all the amplitude samples here. But as we are having a continuity, there are infinite number of samples. If we say, let us suppose we say that okay, we have completed up to this the number of let us suppose 20,000 amplitude samples we have approximated, but we can come with the 2001 sample also, because this is infinite number of samples. So with that we say that it continuous in the time domain. In frequency domain, what will be? It will be aperiodic. Okay, so one thing we know. Now another thing is, if signal is periodic in time domain, if signal is periodic in time domain, what does that mean? In frequency domain, what does it mean? Means that we are having the discrete samples. What does it mean? It means, let us suppose we are having here some signal. It is, we know the time period. By time period we know that we know it is completing its some pattern with some time period t naught, and if we know t naught, we know omega naught. It is the frequency, and we know it will be 2 pi by t naught. If this t is fixed, it is fixed because of the periodicity. So now this t naught is fixed. So what can be the possible frequency? It can be n cross 2 pi by t naught, because this t naught we cannot change. It is fixed now, and we can only change this n, and we can say these n are called harmonics. Harmonics means the integral multiple of the fundamental. It is fundamental 2 pi by t naught. It is fundamental frequency, and this n means the harmonics. It means the integral multiples of this fundamental frequency. So now we will see how we will go from time domain to frequency domain for continuous time and periodic signal. Means if we are having continuous signal, means the t is continuous, and periodic means it is complete, it has some pattern, it repeats from negative infinity to positive infinity. And the second thing is it is periodic, means it repeats some pattern with some time, means we can also say it is a power signal. Now, how we will go from time domain? Let us suppose we have some frequency domain. We are having here frequencies. Okay, we previously said that this will be discrete. Let us suppose this is omega. This will be 1 omega naught, 2 omega naught, 3 omega. Why discrete? Because we are having the periodics in the time domain. Let us suppose we are having 1 omega naught, 2 omega naught. We want to generate from this frequencies time domain signal. So we can say x of t. This is the time domain signal. This is the frequency domain signal. It will be summation. Why summation? Because we are having here the discrete sample. And how we have to go? We have to go from k. K is the this harmonics number, and k is rounding from negative infinity to positive infinity. Why? Because we are having here this omega can be positive and negative, because we are having some concept of positive frequency and negative frequency that will be discussed in the next session. So we will be going from this k will be going from negative infinity to positive infinity, and ck is the frequency coefficient, this frequency coefficient, and we have to multiply it by cj k omega naught t. What this j k omega naught t? It is this omega naught t is a phase. Okay, and this k, it is a harmonics number. Means what type of harmonics of the fundamental frequency it is. It can be the first harmonic, second harmonic. So with that we see that, let us suppose we are having here cosine waves. Sine wave. We are having a sine wave. We know that this sine wave is having some frequency. Let us suppose its frequency is 1 hertz. It is completing 1 cycle in 1 second. So with that we are having here only one frequency component, and we will take that frequency component. So its composition will be then negative infinity to positive infinity, ck e raised power j k omega naught t. So we are having here some frequency. Let us suppose it is frequency is 2 pi. So we will say that c1 will be here 1 by 2. 1 by 2 will be is equal to c minus 1. This c minus 1 will be, and this will be c1. c1 minus 1 will be 1 by 2, and c1 will be 1 by 2. So we will be having minus 1 by 2 e raised power j, and harmonics is first harmonic, and we are having its frequency is 2 pi and t, and plus 1 by 2 e raised power j 1 2 pi, and with that we will be generating this time domain signal. So we have seen here, like when we are having continuity in the time domain, when we are having continuity in the time domain, we are having a periodicity in the frequency domain. This signal is the frequency domain for the Fourier series, means for the periodic signal. It is aperiodic. Why? Because we are having here the continuity in the time domain. And another thing is it is periodic. With the periodic, we see that we are having the discrete samples in the frequency domain. So now we have seen how we will go from the frequency domain to the time domain. Now how to go from the time domain to frequency domain. So for that we will have we have to go from time domain to frequency domain. Let us suppose this frequency domain we have, by frequency domain we are saying that we want to know this frequency coefficient, ck. So ck means k means the harmonic number, which harmonics we want to know, and we have x of t. We will multiply this x of t with the e raised power minus j k omega naught t dt, and we will perform the integration we will perform the integration over the t. This is the fundamental time period. Why we are performing the integration only over one time period? Because the signal is periodic. So we need the analysis over only one period, and this is the exponential. We are multiplying these two, and we will get with the particular ck, and we have to get every k. We have to perform this analysis. So this is also called an analysis equation, and this is called the synthesis equation.